Hi everyone, and welcome to this video going over the Chapter 1 Quiz Study Guide. Hopefully through this video you can understand the study guide a little bit more and be ready for that Chapter 1 quiz coming up. So for all of these questions on the front page, we are going to solve for the variable and identify if the equation has one, none, or infinitely many solutions. So let's go ahead and start with number 1. I'm going to draw my equal sign. And notice how I have a variable on both sides. So I'm going to say that the left is my p side and the right is my number side. Since 1 does not have a p, I'm going to subtract it to both sides. And I subtract it from the 1 since those are like terms. And I am left with 7p equals 7p. Remember, if we ever get the exact same thing on both sides of the equation, we can stop and say that there are going to be infinitely many solutions. Because this means that it does not matter what value I plug in for p, both sides of my equation are always going to be the same. Let's try number 2. So I draw the line at my equals. And once again, I have an x on both sides. So I'm going to say that the left is my x side and the right is my number side. Negative 2 does not have an x, so I'm going to add it to both sides. So I'm left with 3x is equal to x, and 6 plus 2 is 8. Next, the x is on the wrong side, so I need to subtract it. And remember, if we don't see a number, there's an imaginary 1 in front of that x. 3x minus 1x will be 2x, equal to that positive 8. And then since the 2 and the x are right next to each other, that means multiply, and the opposite of multiplication is division. 8 divided by 2 is 4, and so x equals 4. This is an example of when there's only one solution. X can only equal 4. 4 is the only value that we can plug in to make this equation true. Moving on to number 3. I'm trying to get x by itself. I start with what's not attached to the x, which would be the 1. Since it's a positive 1, I'm going to subtract 1 to both sides. 6 minus 1 is 5. And since the 5 and the x are being multiplied together, the opposite of multiplication is division. And so I divide by 5. And 5 divided by 5 will be 1. And so x equals 1. Once again, this is only one solution. This tells us that 1 is the only value we can plug in to make this equation true. Moving on to number 4, I am trying to get r by itself. So I start with what's not attached to r, which is that negative 13. The opposite of subtracting 13 is adding 13. So if I add 13 to both sides, I get r over 3 is equal to 12. Make sure that you do negative 1 plus 13. And in order to get r by itself, I need to get rid of that dividing by 3. The opposite of dividing by 3 is multiplying by 3. And so I multiply by 3 to both sides, and I get 36. This, once again, is only one solution. Moving on to number 5, I have a number in front of parentheses, which means I need to use the distributive property, or double rainbow, which means I am multiplying. Negative 8 times n is negative 8n, and negative 8 times 4 is negative 32. Make sure that when you're multiplying, you use that negative in front of the 8. And that equals negative 96. And I solve like normal afterwards. To get rid of that negative 32, I'm going to add 32 to both sides. And I get negative 8n is equal to negative 64. And then I divide by negative 8 to get rid of that multiplication. When you divide two negatives together, it will make your answer positive. So 64 divided by 8 is positive 8. That is one solution. Moving on to number 6, I have two double rainbow problems to do. negative 4 times 3n and times 2. Let's start with negative 4 times 3n will be negative 12n, and negative 4 times 2 will be negative 8. Next, I need to double rainbow with the 6. 6 times negative 2n is negative 12n, and 6 times 1 is positive 6. Notice how I have an n on both sides, so I am going to label my n side and my number side. Negative 12n is on the correct side, since it has an n on it, but the negative 8 is not, so I'm going to add 8 to either side. And I'm left with negative 12n equals negative 12n plus 14. That negative 12n on the right is on the wrong side, so I'm going to add 12n to both sides. And on both sides they cancel out, so on the left I have 0 is equal to that 14. This is not true. Whenever your variable cancels out and the two sides of the equation don't match, that's when you have no solution. So 0 does not equal 14. That's an example of no solution. Moving on to number 7. Once again, I have to double rainbow. So 6 times 6x will be 36x. And 6 times 2 is 12. In order to get x by itself, I start with what's not attached to the x, which would be the 12. The opposite of adding 12 is subtracting 12. And what I do to one side, I have to do to the other. I am left with 36x is equal to 180. And then to get rid of this multiplication, I need to divide by 36 to both sides. And 180 divided by 36 gives me x is equal to 5. That is one solution. Whenever x just equals a number, that is just one solution. Last one for this side. I have 2 double rainbows to solve. So 8 times 2n is 16n, and 8 times negative 3 is negative 24. Next, 4 times 4n is 16n, and 4 times negative 6 is negative 24. And notice how I have the exact same thing on both sides of my equation. This means that there's infinitely many solutions. Nice, so the first part of your quiz is just like that. A bunch of solving equations, some with double rainbow, some with not, and you have to tell me how many solutions each equation has. Either one, none, or infinitely many. The other part of your quiz has to do with writing expressions and equations. So looking at number 9, it says, Ms. Felberg tutors students after school, and each week there are more students attending. During the first week, only 5 students attended, then 9 students attended the second week. Finally, 13 students attended the third week. Create a table that displays how many students attended tutoring each week, starting at week 0. So I'm going to say week number, and then number of students. And the problem says to start at week 0. Well, I know at week 1, the problem said that I had 5 students attend. Week 2, it says that I had 9 students attend. And at week 3, it says I had 13 students attend. Let's identify the common difference. To get from 5 to 9, I have to add 4. And to get from 9 to 13, I also have to add 4. Which means to go backwards to week 0, I have to subtract 4 from 5, and that gives me 1. And notice how that follows right into the pattern. 1 plus 4 would give us 5. Now that we have our table and have identified where we are at week 0 and what our common difference is, we can write our expression. Your expression will always follow the same pattern. Your starting amount, and this needs to be at 0, plus the common difference, and then your variable. In this case, our variable is n. So at week 0, we had 1 student. So 1 is my starting amount. and our common difference is 4. Every week, 4 more students come, and 4 goes next to my variable. This is my expression. N represents the number of weeks. So in part C, it said, use your expression to determine how many students Ms. Fehlberg will tutor during the 20th week. This means I'm plugging in 20 for N. So I have 1 plus 4 times 20, because notice how the 4 and the N were right next to each other. That means multiply. 4 times 20 is 80, and 1 plus 80 is 81. This means that on the 20th week of tutoring, Ms. Fehlberg will have to tutor 81 students. That's a lot, but I hope that many people come to tutoring. So after you write your expression, N represents the number of weeks, and so we can figure out how many students will be there no matter what week number we plug in. Let's try this one more time. Paloma is going skiing in Lake Tahoe. She needs to buy a lift ticket and rental equipment. The lift ticket costs $150, and the rental equipment costs $50 per hour. Remember, our key words are per, each, every. Those tell us where the variable is going to go. So I know that Paloma spent $150 plus $50 per hour, and so that's where my variable goes. You could also use H for hour if you want to. I'm just going to use X. And she spent $500 in total. So this is an equation to represent how much Paloma spent. B says, what does the variable in your equation represent? So what is X a placeholder for? In order to figure this out, always look at what the question is asking. Notice how it said, how many hours did she spend skiing? And that makes sense because the equipment costs $50 per hour. So we don't know how many hours she spent skiing. So X is hours spent skiing. So always look for what the question is asking you to find, because if we don't know what it is, that must be our placeholder. That's what our variable must be representing. In part C, it says solve your equation and interpret your answer in terms of the context of the problem. So I'm going to draw a line at my equals. If I'm trying to get X by itself, I'm going to subtract 150 to both sides. And this gives me 350. And then I divide 50 to both sides to get rid of that multiplication. And this tells me that X is equal to 7. But notice how it says interpret your answers in terms of the context of the problem. What does X equaling 7 mean? Well, remember, X represents the hours she spent skiing. So if X equals 7, this means that Paloma skied for 7 hours. Make sure you practice interpreting your answers in terms of the context, because when we solve a word problem, our answer actually means something. Please let me know if you have any questions, and happy studying for your Chapter 1 quiz.